இந்த வீடியோட தமிழ் வெர்ஷன் கமெண்ட்ல பின் பண்ணிருக்கேன். மேக் யூஸ் ஆஃப் இட். Welcome to the session on protocol layering. First, we will understand what protocol layering is and why we use it in networks. Then, we will look at two simple scenarios, one with single layer communication and another with multiple layers. In this, we will see how layering helps. After that, we'll discuss the benefits of protocol layering, like modularity and simplicity, and also we will talk about any possible downsides. Moving further, we will learn two main principles of protocol layering. It shows how data flows in both directions and how objects at each layer should match. Finally, we will see how layers on both sides can be imagined as if they are directly connected, what we call as logical connections. So this will help us to understand communication clearly. What is a protocol? In data communication, a protocol is a set of rules. These rules help the sender, receiver, and all devices in between to communicate properly. To be simple, protocol is rules for communication. In networking, computers also need rules to talk to each other. And that's why we need protocols. If communication is simple, then one protocol is enough. If communication is complex, we divide the job into smaller layers. Each layer has its own protocol. That is, it has its own job and rules. This method is called protocol layering. Now let's understand protocol layering in detail. Protocol layering is a method used in computer networks to break down complex communication tasks into smaller parts called layers. Each layer has its own job and follows specific rules called protocols. And why we use layers is, it makes design and understanding easier. It helps in troubleshooting. It allows changes or updates in one layer without affecting others. Each layer does a specific function, so work is well organized. For example, in OSI model, there are 7 layers. Each layer talks only to the layer above and below it. They use clear rules called interfaces to communicate. This keeps each layer separate and independent. If you change one layer, like fixing or updating it, it usually doesn't affect the other layers. So this makes it easier to update, improve, and manage the network system. Now let's see some example scenarios to understand protocol layering. Scenario 1 is about simple communication and it happens using one layer. Imagine Maria and Anne are neighbors. They meet face to face and talk. Even this simple chat has rules called a protocol. They greet each other, one talks and other listens. They keep the conversation friendly. Both should get a chance to speak, not just one person talking all the time, and say goodbye nicely before ending the conversation. This is different from a professor teaching in a class. In class, the professor speaks most of the time. It is often referred to as monologue. And students raise their hand to ask questions. The talk is formal and focused only on the subject. So even simple face-to-face talk needs rules. And depending on the situation, different protocols are followed. Second scenario is about complex communication and it happens using multiple layers. In this scenario, Anne has moved far away for a job and she wants to keep in touch with her friend Maria. So they decide to send letters by post. But they want to keep their ideas secret. So they agree to use encryption. Encryption means secret codes. Encryption is a process in which the information is converted into secret codes so that others cannot understand if they see it. Encryption is used for privacy and security. Decryption is a process in which the secret code is converted to original message. The person with the correct key can do it. Decryption is used for reading the original message safely. And if we need to handle writing, encrypting and mailing, how many different jobs is that? It needs 3 different jobs. Therefore, we need 3 layers. Communication happens in 3 layers. Now let's assume that Anne and Maria each have 3 robots that can perform the task at each layer. Let's assume Maria sends the first letter. Maria talks to the 3rd layer machine as if talking to Anne. The 3rd layer machine listens and creates the plain text. That is a normal English letter. Now this plain text is passed to the 2nd layer machine. The 2nd layer machine takes the plain text, encrypts it and creates the ciphertext. This ciphertext is passed to the 1st layer machine. Now the 1st layer machine takes the ciphertext, puts it in an envelope, writes the sender and receiver address and sends it by mail. Now at receiver side, that is from Anne's side, the 1st layer machine picks up the letter from Anne's mailbox. It checks the sender address and sees it is from Maria. Now the machine takes the ciphertext out of the envelope and gives it to the second layer machine. The second layer machine decrypts the ciphertext and creates the plain text. Now the plain text is sent to the third layer machine. The third layer machine reads it like Maria is talking to Anne. Now in this scenario, protocol layering enables us to divide a complex task into several smaller and simpler tasks. For example, we could have used one single machine to do all three jobs, that is for talking, encrypting and mailing. But if Maria and Anne feel that the encryption is not strong, they would have to replace the entire machine. In the current layered setup, they need to change only the second layer machine, which does encryption or decryption. The other two layers, that is talking and mailing, can stay the same. This shows the advantage of layering. This is referred to as modularity. Therefore, it is flexible and easier to update. Now, what is modularity? In this case, it means independent layers. The layer is often referred to as modules. Each module functions as a black box, which means its internal workings are not relevant to the user. Only the inputs and outputs matter. So this allows flexibility and interchangeability among different components. If two machines give the same output for the same input, they can replace each other. For example, Anne and Maria can buy the second layer encryption machine from two different brands. As long as both machines take the same plain text, give the same ciphertext, and do the reverse correctly too, they are interchangeable. One of the advantages of protocol layering is separation of service and implementation. Each layer gives a service to the other layer above and uses services from the layer below. The internal working of the layer are not important, only its functionality matters. For example, Maria can perform the mailing job manually instead of using a robot for the first layer, and the system still functions properly. Another advantage of protocol layering is intermediate systems use only needed layers. In networks like internet, communication often passes through routers or switches. These intermediate systems need only some layers, not all, and thus layering allows them to be simpler and cheaper. Therefore, without layering, middle devices like routers would need to be as complex as full computers, which would make the system more costly. Now, what is the disadvantage of not using layers? Some argue that having a single layer simplifies the system. That is, there is no need for each layer to provide services to both the upper and lower layers. For example, Anne and Maria could create one machine that performs all three tasks. But the drawback is, if a function like encryption fails, they would need to replace the entire machine. So with layering, only the broken layer need to be replaced, not the whole system. Now let's discuss two principles of protocol layering. The first principle of protocol layering says if we need bidirectional communication, then each layer must be able to do both tasks, one for sending and one for receiving. That is, every layer must be able to do two opposite tasks. Therefore, the layer handles both directions of communication. For example, the third layer task is to listen in one direction and talk in other direction. The second layer encrypts data in one direction and decrypts it in other. First layer sends mail in one direction and receives mail in other. The second principle that we need to follow in protocol layering is the two objects under each layer at both sides should be identical. That is, the object under each layer at both communication sites must be identical. For example, the object under layer 3 at both sides should be a plain text letter. The object under layer 2 at both sides should be a ciphertext letter. The object under layer 1 at both sides should be a piece of mail. After following the two principles, we can think about logical connections between each layer. This means we have a layer-to-layer communication. That is, a logical connection between same layers on both sides. It is like layer 1 is talking to layer 1, layer 2 is talking to layer 2, and layer 3 is talking to layer 3. These connections are imaginary, not physical, but they help us to understand how data flows. Now look at the diagram. It shows how communication happens between Maria and Anne using protocol layering. Each person has three layers. Layer 3 is all about talking and listening. Layer 2 focus on encryption and decryption. Layer 1 is responsible for sending and receiving the mail. Now here is the key point. Even though the message physically travels from Maria to Anne, we can imagine that the same layers are communicating with each other. This concept is called logical connection. Now think like this. Maria's layer 3 is chatting with Anne's layer 3. They are just passing plain text like a normal letter with no secret code. Next, layer 2 is sending encrypted messages, that is ciphertext, to the layer 2 on the other side. And layer 1 handles the mail, like envelope moving from one person to other. These are not real wires or physical connections. They are imaginary, but they help us to understand how communication flows layer by layer. And this is all about protocol layering and logical connections between layers.